Okay, so let's quickly go through the claim in our manuscript fractal MapReduce decomposition of sequence alignment that we provide a USM library, so a library that encodes for the procedure described in this paper. And it's, let's go down. If you go to availability, this is where you can find both the web app, the graphic user interface that uses the library, and I'm also going to show you how can you use the same library from the command line. So starting with the paper, you see that the web app has 4 sections. The same 4 sections have the results of the manuscript. Quickly, results, there we are. So first of the 4 steps is encoding, alphabet extraction, and map compaction. And the examples we give in the paper always refer to this ability to run code on the command line. So let's have a look. Actually, let's start with this example here. Extracting an alphabet from a sequence. Now, this is Chrome. Firefox through Firebug, Safari, Internet Explorer will have the same feature, which is you can peel the browser and look at the command line underneath the browser. So if you go to Developer Tools, in this case in Chrome, you can just copy paste, and there we are. We find out that this sequence has an alphabet that has a CGT. So the rest of the manuscript describes procedures just like this one. For instance, here we could encode for the base sequence. Here you are, and now inside you find both the results and the methods used to do this encoding. For instance, here you find the coordinates for each of the units of the sequence. Here you find the alphabet, and somewhere down here we have the cube, AC and AG, which is what is shown here. So if you put U base cube, you should be able to see the 2 axes. So U base cube, there we are. Now you could also use, of course, the GUI, the web app, which uses the same library. So I'm just copy pasting the code here, and now you get the entire encoded coordinates here. Now a few notes about the interface. So you can of course put values here and here to decode them. To give you an example, let's go further down. For instance, we could decode an individual unit. There we are. Something, see? 011, 011, 011, 011, etc. And they could also put individual coordinates. So we are now at step 2, decoding. We could go here, coordinates. And we get a result. Another example that is given in the manuscript is comparing 0.01 with 0.001. You find out it's 6. You could find out what these 6 are. 0.01 is 1, 2, 3, 4, 5, 6 zeros and then 1 and some more 1s and zeros. So remember 6 zeros. 0.001 you have more zeros, and which means that you have 6 zeros in common. Now if you move your mouse on top of any of the coordinates, they are automatically moved to this box. You can write your own, of course. You could say this and the sequence would be different, but this saves you some work. Instead of having to copy the coordinates individually, you can just move the mouse. Now note that this segment here is produced by having the coordinates copied to this box and having the strings put here. Okay, before we move to more things we can do with the command line, I'd like to show you the probe and then the MapReduce operation. Okay, here we have the probe sequence. So again, if you copy it, there you are, you have the full sequence. If you have twice a sequence, you get an identity matrix. For instance, if I get this sequence and do it twice, let's start from the beginning. So 1, 2, you now get the identity matrix. You see from figure 1 that the circular encoding means that the sequence is stitched to itself, both ends, which means that we are comparing an infinite sequence. And that's why we get a number that is as large as the numerical resolution of the processor of your machine allows you. You also see up here the calculation of the distances between individual units. So the map operations goes from here to here, from here to here, and then the reduction goes back to the ends here and to a single number in the end. Okay, let's see what else I should show you. Of course, you can do any of these on the command line. For instance, you could say la equals to new USM, now a sequence, it doesn't matter what it is, and you have the same analysis for this sequence. This is the alphabet used. Now you're looking at a cube with 4 dimensions instead of 2, and the coordinates encoded here. Just to finish, so the rest you can get from the manuscript by just copy-pasting and finding out individual operations. To finish, the demo as concerns directly what is shown in the paper. I'd just like to show you the resolution of equation 6, which has 2 map operations. It's probably the most impressive demonstration in the paper. So you have U-base being compared to U-probe. First, let's make sure we have U-base and U-probe. And if you go to table 3, there's a convenient set of 3 lines with the commands you need to run in the command line to have all of these functions ready for you, all of these variables ready for you. Okay, so now let's run this command here, which is the same one that generates the table we were looking at. Now you have this array. If you want it to see as a string, you just use the browser's native JSON object. There we are, and we have the same strings, the same tabular string. Now, stepping a little bit outside the paper, just want to show you that the advantage of using JavaScript go beyond the ability to reproduce the functionality captured by the GUI, by the graphic user interface, the web app, whatever you want to call it, of a JavaScript application. So for instance, if we go to New York Times, there we are. Now I'm going to peel the browser and show the command line, all these ugly things related to what goes on in New York Times. And now if you type USM, of course USM is not there. Now how hard it is to programmatically import JavaScript library from a remote location. So here we go. I'm doing this as primitively as possible by using only the document object model functions. So document, and now I say create element. I'm going to create a script element, and then I'm going to point it to the USM library. So notice here USM did not exist. So I created a script, and I'm going to say that the source of this script is equal to USM USM.js. And now I'm going to put this somewhere in the document. So for instance, the body or the head, it doesn't really matter. I'm going to say append. Child, yes. And you see that the script was now read and the USM library is in there. So I could do just as before, USM or voila equals to new USM and awesome. Oops, this has to be a string, of course. Something doesn't know what it is. And there we go. That show you how the universal sequence maps can be used to decompose sequence analysis to its limit. And after the paper is published, we hope we'll have a better version of this video with more details and pointing to the final version of the manuscript. All right, thank you.